Welcome back, everybody. We are talking about organic loading to a digester with a sloped floor. So this is an intermediate and an advanced math problem woven into each other. Okay, so organic loading to a digester is your intermediate problem you'll probably see on a grade 3, California grade 3 and equivalent, which would be, like I said, intermediate. With a sloped floor, when given a gradient, is going to be more of an advanced math problem. You may be given the actual floor height. I think I remember being given a gradient though. So I want to show you how to do that in case you bump into it. It's not hard, but it's yet another layer of the onion. It's another step where they are just, so the advanced math, the grades 1 through 3 in California, the beginner and intermediate stuff, you have some pretty cookie cutter math equations you need to know. When you get to the grades 4 and 5 or your advanced math for other states, the playbook's kind of different. It's like whatever they decide, they're going to throw at you. Okay, that could be all sorts of iterations. There's no one math equation I'm going to be able to teach you that is a silver bullet. You're kind of going from knowledge to understanding on the advanced math. And I think there's a reason they need you to have so many years experience to take these tests, is because you kind of need to visualize what they're talking about and have seen it in some way, shape, or form. So what I'm going to do here, I'm going to explain, I'm going to distill down our information, of all this stuff. There's some tricks in here. There's some smoke screens, and I'll explain those when we get there. You will get smoke screens, especially when it comes to organic loading to a digester. And then if you stick to the end of the video, I'll show you all the different ways that this might be pitched to you and some other things you might run into and previews of future math problems. Okay. And before we jump in, if you find any value in this video, please like, subscribe, pass it to your friends. Let's help folks get certified. All right, so I'm given a digester. It's going to be a cylinder, more than likely, a cylindrical digester. I don't know of a ton of square digesters out there. And you're going to have a sloped floor towards the center, okay? This is going to change if it's a sloped floor going this way, all right? The math is going to change. But I'm going to go ahead and just assume they're going to give it to you to the center. That's what I've seen, and that's probably the most common situation for a digester. Okay, if you know differently or you've seen differently, please put it in the comments below. But yeah, slope towards the center. These are all the things you're going to be given. We have a diameter, we have a height of the tank, we have a gradient of the floor, we have a raw sludge total solids percent concentration. We have a raw sludge volatile solids concentration. You have a pump flow. This is going to be your sludge pump from the primary or your thickener or whatever. Pump flow. You have a pump timer. We're going to have a plant flow, a BOD load. How many digesters we have, and they're going to ask how many of these digesters should be online if you have a target of 0.2 pounds volatile solids per day per cubic foot. They might leave volatile solids out of there because your smoke screens in here are plant flow and BOD. You need to know that it's pounds of volatile solids per day per cubic foot to a digester. BOD is an irrelevant number, okay? BOD is loading to secondary processes. Now, plant flow might matter if they package this a different way and they give you the amount of TSS settled out. They might give you the influent TSS and the effluent to the clarifier. You got to figure out how much settled. That may be relevant. So that I guess I'm just telling you now instead of at the end of the video. That's one way that it might show up. But this is how I decided to do it, is with the pump flow and the pump timer. So the first thing I'm going to do, I'm going to start looking at those units, pounds per day per cubic foot. Well, how can I find pounds per day? I know it's volatile solids. So let's see, is there anything in here I can do to pull out and make a pounds per day math formula? Well, I've got pump flow, okay, so I've got flow. That only gives me gallons per minute. How do I figure out, pump timer, 1 minute per 20 minutes. Oh, okay, so I know if I were to divide 60 by 20, 60 minutes in an hour by 20 minutes, that's 3. So there's 3 1-minute cycles in an hour. Okay, so that's 3 minutes right there. It didn't tell me that there was a set hours per day, and they'll do that to you. You might see, and it ran for 10 hours. So keep your eyes peeled for that. But it didn't tell me that here, so I'm going to assume 24 hours in a day. Okay, great. I've got 125 gallons a minute times 3 minutes per hour times 24 hours in a day gives me 9,000 gallons per day. Divided by a million, 0.009 mgd. Well, we're starting to shape up a pounds formula, aren't we? Okay, well, I need a concentration. What am I sending to a digester? I'm sending sludge, aren't I? So I have a raw sludge total solids percent or concentration of 3.1%, or for all of you who are aware, 1% is 10,000 milligrams per liter. So that is a concentration of 31,000 milligrams per liter. Well, my loading rate to a digester is not total solids, is it? There's inert matter in there. It's volatile solids. So my volatile solids percentage is 74%. So now I'm going to multiply that by 0.74. If you plug that whole thing in your calculator, it should give you 1,722 pounds per day. Boom! We got our first step done. We're cooking. So all I have to do is find out my cubic foot, right? Well, this is a curveball for me because I don't know much about gradient. What does that even mean? Gradient is 1 to 2. So let's talk about floor gradients. Gradient equals rise over run. Okay, the rise of the floor divided by the run. So we've got 1 over 2. We need to rearrange this to find the rise, and that's going to equal gradient times run. Okay, so we know our gradient, and we know our run, don't we? So what is that? I guess I put these arrows in the wrong spot. Our gradient is a 1 to 2, or 1 divided by 2, or 0.5. Okay? If you have any questions about that, put it in the comments below. So our gradient is 0.5. That's going to go right there. Our diameter is 16 feet, isn't it? And we're going from the center, which is the radius. We're not going all the way across. We're going from the center to the wall. We're trying to figure out what the floor height is. And that's 8 feet, isn't it? So our run is 8 feet. So our rise is 0.5 times 8 equals 4 feet. Our sloped floor starts at 4 feet. If you have any questions about that, comment, please. By the way, they may give it to you. You may not have to do that, but please do know how to do that. It may serve you very well. And if you've run into gradient on your exam, please put it in the comments below. Okay, now we have the floor height. We can do cubic feet. So where I start with this is I take these two pieces and I separate them from each other. Okay, so I have a truncated cylinder and I have a cone. These are very simple geometric equations. We do cylinders all the time, so let's pop that out first. 16-foot diameter, 0.785 diameter squared, times 16 foot tall. This is a 20-foot tall tank from bottom to top, but we know our floor height is 4 feet, isn't it? Or yeah, 4 feet. So 20-foot height tank minus 4 feet is 16 feet. That's where I got that number. That gives us 3,215 cubic feet. Okay, now we do a cone. We have a floor height of 4 feet, diameter of 16 feet, and how you do a cone is 1/3 times 0.785 diameter squared times height. So I just do that. I like to multiply as a decimal, and so 1 divided by 3 is 0.33. So 1/3 is 0.33 times 0.785 diameter squared, which is 16 foot squared, times 4 gives us 265 cubic feet. Plug that in your calculator. And now we add them together to get the total volume of the digester, which is 3,480 cubic feet. Now we have our pounds per day. Now we have our cubic feet. Now we can do our organic loading to the digester with our sloped floor. 1,722 pounds per day divided by 3,480 cubic feet gives us a 0.49 pounds per day per cubic foot of volatile solids. Well, our target's 0.2 pounds per day per cubic foot, isn't it? And by the way, the range of a high rate digester is anywhere between 0.15 to 0.4. I've got some study material that's very highly respected in California that pounds the table that you should be looking at a 0.2. So if they don't give you a target, you should probably assume a 0.2, but they should give you a target if they're asking you to do the next step. That's quite high for a digester, 0.49 pounds per day per cubic foot. So what we're going to do is we have 4 digesters at our disposal that are identical. How many do we use if our target is 0.2 pounds per day per cubic foot? How you do this, you take your organic loading and you divide it by your target. So 0.49 pounds per day per cubic foot divided by 0.2 pounds per day per cubic foot, again, our target, gives us 2.45. So we should be using 3 digesters, because you can't use half a digester, if that makes sense. You put 3 of the 4 digesters online. Okay, I hope this helped. Please ask questions. if there's a math problem you want worked out, please let me know. Like I said, like, subscribe, pass to your friends. Let's help folks. Tell us what you've seen on your exams. Let's help folks here. Like I said, it's freestyle when you get to the grades 4 and 5. You don't know what they're going to do. Like I already said, they might drop out solids in the clarifier, or what they might do is, there's a lot of other things they're going to do. We have a lot of math problems that are going to be coming out on this channel. I actually don't want to confuse anything anymore. Let's just let's just stop it here, and I'll get on my rambling tirades, and then we're going to be here for another 5 minutes. So anyway, thank you for joining me today. I hope this helped. And questions, again, comments below. And I hope everybody has a great day.